Hey, welcome back to Mr. PFs with Precal. This is Unit 2, Topic 1. This is lesson number 4, which we're going to be talking about, in this case, change of base property. We're going to start off with a quick warm-up on changing exponential to logarithmic form and vice versa. So this will be log base 5 of 125 equals 3. So remember, this is b to the y power equals x, and log base b of x equals y. Now, the x and y, the x here is the output and the y is the input. Well, here the y is the output and the x is the input. Because the nature of inverses, the x and y just simply switch. And then the bases stay the same. So the base here is 2 in exponential form, so it's going to be log base 2 of 64, because keep in mind that was the output of the exponential. So that becomes kind of like the input of the logarithmic, and then the output is the 6. So when you read this, it would say, what power of 2 is 64? Well, 2 to the 6th power is 64. Now going backwards, this will be 2 to the power of 3 equals 8. So 2, that's base 2 to the y power equals the x. And this will be x to the 5th power equals 243. Now, of course, x would be 3, but it didn't ask us to solve. It just asked us to set it up. Of course, I would do 5th root of both sides and see that the answer is positive 243. All right, so why do we need to use change of base? Well, what if you have a question like this, log base 4 of 7? Well, there's no power of 4 that equals 7. 4 to the first power equals 4, and 4 to the second power equals 16, and 7 is in between 4 and 16. So we know the answer is going to be somewhere between 1 and 2. Most likely closer to 1. Keep in mind, you can't just say where it is in relevance. You can't just say it's closer to 4 than 16, technically, although in this case it does happen to be true. So in this case, we know the answer is 1 point something, give or take probably 1.2, 1.3, somewhere in that neighborhood. But we need to find a way of figuring this out. So what way we're going to do that is we're going to follow these steps right here, which we're going to switch it to exponential format. So that would be, so I set this, let me move myself for a second, set this equal to x. That would be 4 to the x power equals 7, just like we did on the warm-up. Then I'm going to take log of both sides. So as long as I do it to both sides, then the equation is going to stay the same. And then I'm going to use, okay, so this isn't right. So I'm going to use the power property, which states that anytime you have a power of an x here, which happens to be the letter x, then you can move it to the coefficient. So x times log of 4 equals log of 7. Now that I have it multiplied, because it's the coefficient of this log of 4, then I'm going to use my division property of equality. I'm going to divide both sides by log of 4. And then what you'll notice is that x equals log of 7 over log of 4. So now this is in base 10. Actually, I can make it any base that I want. So at this step right here, I could have done log base 2 of both sides, log base 3, log base e. It really doesn't matter in this case, as long as you do the same thing to both sides. So which tells me that I really can make the base whatever I want. Now, why is it important? Why is it good for me to make it base 10? Because that's common log. Because all calculators, any scientific calculator is going to have a log button on it. What only some scientific calculators, only TI-84 pluses with certain software apparently, can only do these questions when it's a base other than e and common log. So that's why this is useful. So I can now put this in the calculator, and it's going to give me a rough estimate because it's going to be an irrational answer, give or take. And this is also something that you're going to be helpful when we start solving log equations. All right, so this time it's got the right notes over here on the left-hand side. So I'm going to do the exact same thing again. So I'm going to change it to exponential. First set it equal to x because we don't know what the answer is. So that's 3 to the power of x equals 16. Take log of both sides. And once I do that, then I'm going to use the power property to push the x out in front, because x times log of 3 is the same as as log of 3 to the power of x, because this is the same as this. It's equal to log of 16. And then I'm going to divide both sides by log of 3. Now, x equals log of 16 over log of 3. Now, typically, I'm not going to go through all this process. Typically, if you look right here, you can see change of base is actually pretty simple. As a matter of fact, you are just really doing log of the x divided by log of whatever the base is. So if we have, let's say, log of base 7 of 12, okay, that would be log of 12 divided by log of 7. And I don't need to go through all these steps. It's always going to be log of whatever's in the x spot, which is the big number, and divided by log of the base, which is the smaller subscript number. All right, so using the same idea, so it's given to me in exponential format. So I'm doing the same thing here. I just have one step already completed. So I'm going to do log of 12 equals log of 5 to the x. Push the x out in front. Log of 12 equals x times log of 5. And then divide both sides by log of 5. So x equals log of 12 over log of 5. And then it will be the same stats for all the rest. I think I've done enough of those. As a matter of fact, this is going to be a pretty short video because in the end, change of base really is pretty easy of an idea. So it's going to be, so if I skip everything that I was doing a second ago, so you can use common log or natural log because they are both on a, like I said, like on any scientific calculator. So I could say natural log of 175 over natural log of 8. So it's just going to be this on top and this on bottom. Or you could say common log of 2 over common log of 0.5, which is going to give you a decimal answer, as you'll see. So if you put this in a calculator, once again, you're going to get an irrational answer, which means you're going to have to round that answer in order to write it. Whereas this is an exact answer. This is, most of the time, this is probably the way you're going to keep it, unless the direction specifically asks to round it to something and change it to the nearest number. So this will be log of 12 over log of 5. Now, I know my handwriting is not the greatest, but this is log of 5. It's not base. So I changed them both to base 10. Technically speaking, although it wouldn't really help you any, you could change this to any base. You could say log base 7 of x over log base 7 of 3. That's going to be the exact same thing, but like I said, that really doesn't get you anywhere because with a regular scientific calculator, you're not going to be able to put this in, and you are pretty much in the same place that you were to begin with. So this isn't really beneficial, which is the reason why we suggest that you use either common log or natural log. All right, I'll do this one. It's not really going to change anything, though, so it's going to be log of a plus b. Now, we don't know what a is. We don't know what b is. We can't really add these two over log of 2. So nothing's really changed here. It's doing the exact same process. This would be log of x plus y over log of 0.5. All right, thanks again for watching, and please give it a like to help you learn something about change of base. Hopefully I made this a pretty easy property when it really comes down to it. Now, the reason why, I did explain the reason why change of base does work, and maybe that's not as easy to follow and understand, but hopefully when you see it now that it's really just log of this, log of the x spot, so that when I say the x spot, log of base b of x equals y, so it's log of this over log of this equals your y. All right, thanks again for watching. Have a great day.